On this episode, we are talking about digital electricity. Welcome to the show where we tackle the tough questions submitted by installers, estimators, designers, project managers, customers, everybody in the ICT industry. We are connecting at the human level so that we can connect the world. If you're watching this show on YouTube, would you mind hitting the subscribe button and the bell button to be notified when new content is being produced? If you're listening to us on one of the audio podcast platforms like Apple Podcasts, Google Play, Stitcher, or any one of those, would you mind leaving us a 5-star rating? Those couple little steps helps us take on the algorithm so we can educate, encourage, and enrich the lives of the people in the ICT industry. Thursday nights, 6 p.m. Eastern Standard Time. What are you doing? You know, we do a live stream where you get to ask your favorite RCDD, well, that would be me, your questions on design, installation, certification, estimation, project management, even career path. I can hear you now, but Chuck, I can't watch a video while I'm driving my truck at 6 p.m. on Thursday nights because I'll crash and then I'll get in trouble. That's okay. They are recorded and you can watch them and consume them at your convenience. To get access to them, just go to letstalkcabling.com. You'll find the tab for the live streams. It's on there. You'll find it. And finally, while this show is free, and it will always remain free, if you would like to support this show to help offset some of the costs, you can do so by going to Patreon, going to our webpage, going to the Amazon links page. You can support us through PayPal. You can support us through Linktree, where you can buy me a cup of coffee. You can even schedule a 15-minute one-on-one call with me, of course, after hours. Also, we are looking for corporate sponsors. So if your company's platform is similar to ours to educating, encouraging, and enriching the lives of people in the industry, make sure you get in touch with me. Let's see if we can't work together. As I mentioned in the intro, digital electricity. What is it? How's it different from PoE? Is it safe? What all's involved? Can I do this as a low voltage installer? Can I do this as a low voltage contractor? These are all kinds of questions that I came up with just as I started reading the articles on them. So like I said, you always got to find somebody who's more knowledgeable than you. So I happened to come across on BS with Todd on his podcast, Luke Getto with Volt Server Communications. Luke, welcome to Let's Talk Cabling, my friend.
Hi, Chuck. Thanks for having me.
It's a pleasure having you here. So let's start off with, who are you and who is Volt Server?
Sure. So as you mentioned, my name is Luke Getto. I'm the Director of Product Management and Marketing at Volt Server. Been with the company just over 2 years. Before that, I was primarily in the wireless space, wireless communications. I got my start out of college working on part of the GPS satellites that are helping your Uber drivers find you right now. And then moved into the commercial space, working on equipment, for CommScope in the commercial DAS space, one of their platforms. Then I moved over to Microlab, again, another wireless component company serving the likes of AT&T and Verizon. And now I'm here at Volt Server. So I found the place because of their reputation in the DAS and the telecom space. Knew a lot about them and was eager to work with them. So now I'm here and talking about power distribution and what digital electricity can do in the world and for you.
Very cool. So how long have you been in the ICT industry in years, would you say?
It's going on probably about 15 plus years.
Nice. Very good. So you mentioned digital electricity. What exactly is digital electricity?
All right. So what I like to describe it as, everyone is familiar with their AC outlet in their wall. Everything in this office you can see behind me is powered by a single breaker down in my garage, right? I got my fridge, my printer, my workstation, my lights, my space heater over here because it's freezing in New Jersey, and nay, a complaint from my breaker, right? But it's dangerous, right? That's why you got to put those plugs in the wall when your kids start crawling around so they don't shock themselves, right? Now, a lot of people probably, on your podcast, very familiar with Power over Ethernet, PoE, right? Great technology, but it's limited in power and distance, right? Roughly 100 watts, 100 meters, or 300 feet. So great technology combines power and data, but it's limited so it can be safe. So it can be run by your low voltage installers according to code, right? So what digital electricity does is it bridges the gap. We're bringing the power levels of AC outlet with the safety and installation practices of power over Ethernet. And how we do that is through digital electricity. So we are sending a high voltage DC pulse. Sounds very dangerous, right? High voltage DC along the line, but we're pulsing it and we're turning it on and off 500 times a second. Every time we turn it off, we run a safety check. If the safety check passes, you send another pulse. Safety check passes, send another pulse. If it fails, you stop sending those packets, those pulses of energy. So the amount of energy dissipated into a fault is very, very low. Feels like a mild static shock.
So, exactly how much energy are we talking about?
So right now, we're able to deliver 600 watts per pair of copper. So we, on a single channel that we call digital electricity, which is a plus and a minus, a pair, we're doing 600 watts out of our transmitter.
And so, is it limited to amps as well? Because here's what I'm thinking: could I run my entire house off of digital electricity?
It's possible. We have some employees that are doing some stuff like that. Right now, we're mainly in the commercial space, whether that's a telecom system like a DAS, 4G, 5G, a technology overlay like power over Ethernet, IoT, stuff like that. A lot of our stuff goes into an IT rack and an IT closet. I don't know many people that have an IT closet in their house. So besides maybe you and me.
Some of
But
us
yeah,
have one.
yeah.
Actually, I know a lot of people that have them. So I guess so you're running a cable from a centralized point to the device. What is it
Mhm.
terminating on? Is it terminating on like an APAC connector? Or is it terminating on a traditional
It's
jack,
like
a
a terminal
traditional
block.
electrical jack? A
Yeah, it's
what?
just a terminal block, so it could be screw terminals, a Wago connector, things like that. We don't have a specific, proprietary connector that we use. We tend to just like, what's available out there on the market, what you can get easily.
Gotcha, gotcha. So is it safe? I know you said you had that does that 500 pulses and
Mhm.
it does a safety check. What exactly is that safety check? What is it looking for?
Sure. So it's basically looking for an open, a short, a touch fault, an arc fault, all the above. What we're doing is we are doing, it's a fault managed power system. So it's looking at the conditions of the power delivery. And if anything around those conditions changes, we turn off right away. And, you mentioned safety. So we say it's safe, but we are a limited power source listed to UL 62368-1, which allows us to be, deployed as a class 2 circuit in a building. So yes, it's safe. It's as safe, if not safer, than power over Ethernet, um, because we are limiting the energy input to a finite amount that falls within the safety characteristics of the UL standards.
So you say that it's doing these 500 pulses and then it's doing a safety check. That doesn't sound like an electrical distribution panel. Is what exactly is at the head end of that?
Sure. So what we have is what I call a bookended system. On one side, we have our transmitter. So the transmitter converts your conventional AC power or DC off a DC battery plant to our digital electricity. Then you can run that over either, a multi-conductor cable, a hybrid fiber cable, out to your remote location where you want to deliver that power. And then you have what's called a receiver. So the receiver converts digital electricity into whatever format of electricity you need at that place. So we have different models of receivers: AC power, high voltage DC, low voltage DC, 48, 54 volts, things like that. And that then it tells you how much power it can deliver. And so we, as I mentioned, you take that 600 watts pair and we can combine multiple pairs. So you can talk over 2,000 watts being available at that receiver, which can be, 1,000 feet away or even up to 1,000 feet away.
Gotcha. So this head and unit, how is it? How big is it? I mean, is it like a server or is it like
Mhm.
a big big cabinet?
Yeah, I mean, I like to kind of talk about it as a power server, right? So it kind of looks, we have two models. One is our kind of enterprise unit, which is 1U. It has 8 channels, so each channel do up to 600 watts. So that's a hefty amount of power, right? Then you have our high density units, which can be for larger installations where you're going to have lots of loads, lots of locations, things like that. So that's 2U. So they're pretty compact. Think of it like a PoE switch, 1U for 48 ports, another, 2U for whatever. So they are pretty compact, and they do tend to look like, kind of IT equipment.
Now you said I got that Headend unit, right? So now it's running over that. You said it was a multi-conductor cable. I noticed you picked your words carefully. I tell people all the time, words have meanings. And so when
Mm-hmm.
somebody's very specific with their language, my ears always tune in, right? So what do you mean by multi-conductor cabling? Are you talking about a category balanced twisted pair cable, or are you talking about something else?
Yeah, not a category cable, but a structured cable. Multi-pair, twisted pair. Excuse me. So as I mentioned, we like to we're able to combine the pairs. So typically, what we're recommending is rather than home running a single pair out to a remote location, you're going to take 4, 8 pairs, maybe even 16 pairs out to that location. So today, you may only use a small set of those pairs, but we like to call it dark copper. So you might be familiar with the term called dark
Yeah.
fiber.
Yep.
Well, if you're going to run a cable, a lot of that cost is in running the cable, right? So rather than
Mm-hmm.
pulling a single fiber today and finding out you need more bandwidth later, just pull a bunch of fiber, right? Pull more than you think you need. Same thing with the copper. So we're doing either 16 or 18 gauge copper, to get that kind of flexibility, as well as the thickness for, delivering that much power over distance. We're not breaking any laws of physics here. So bring out, several conductors. As I mentioned, there's a 600 watt per pair. Obviously that, reduces with distance. So we got to do some power distance calculations. Bring out some extra pairs out there that you say, hey, I'm going to power up this PoE switch in this closet. But maybe tomorrow I want to bring another PoE switch out. Maybe the building owner wants to upgrade. You don't want to have to go, well, we did this installation for you before, but we didn't pull enough cable. So you're going to have to pull more cable at that location. So we can go inside a hybrid cable, which has those conductors. Then you've got power and data in a single cable, pull, practically anywhere you want.
Gotcha. So this cable, would it look similar to like, the old RS-232 cables we used to install?
Uh, it might, yes. There are a lot of manufacturers out there we work with. I don't like to play favorites, but there's definitely some conductor cable manufacturers out there who advertise digital electricity cables that we work closely with. We have what we call our cable table, is all the cables we've looked at, we've tested, we've approved. We want to be sure that anybody who's out there deploying our gear, it turns on right the first time.
Right, right. Yeah, my show's agnostic. I don't endorse or talk bad about any manufacturer of anything because everybody's got a place in this industry. Everybody's got a place in this
Mm-hmm.
industry, and that's why I don't talk about manufacturers typically. So now we talked about the head end unit. We talked about the cabling. So talk to me a little bit about that device that you said is the end, right? I imagine it's
Mm-hmm.
kind of like a PoE injector and a PoE device. Is it something like that? I mean, are we talking, something about the size of an injector, or is it something bigger to convert it back over?
Yeah. So there's a few different models. It depends on how much power you need, at what distance, and in what format. And by format, I mean AC or DC, right? So we have our DC, receivers that can put out 54, 48 volts. We've got a 1200 watt version. We've got a 300 watt version. We've also got a 2000 watt version. Then you have our AC inverter that will put out, 208 VAC at about 1400 watts. So each one has a little bit of a different form factor. Depends where you want to use it. Some are outrated. So I mentioned, 5G radios. Some of these 5G radios can pull 1,000 watts or more, and they're outdoor rated IP65. With the overvoltage protection, things like that. Whereas our AC unit is more intended for an IDF or an IT closet deployment, where it's going to be plugged right into a PoE switch below it. So it's got, a regular, I believe it's a C20 plug, You plug it into your PoE switch, and now you've powered your entire, PoE network from that location using digital electricity.
Gotcha. How did digital electricity come about, and how long has it been? How long have we been dealing with it?
Sure. So the company was founded about 10 years ago by Stephen Eves, who has a long background in the energy business. And his idea was, look, he's seeing this trend, even 10 years ago, of electrification of everything, right? We want
Hmm.
to move electric to all these different things and power things with renewable energy, right? But just take an example of the vehicle, right? The electric vehicles, right? So let's say everybody converts to electric tomorrow. Great, that's fantastic. But everybody's got to get these plugs, right, installed in their garages, right? Yes, you can use the plug that's there, but it might take quite a while to get up that charge. So now you've got this dangerous, DC that they're these ultra fast chargers that's plugged
Hmm.
into your vehicle, and now you got your kids, they run around, they're not paying attention, they over this cable. I mean, that could be deadly, right? So his vision was, how do we make a high power delivery safer? Even as I mentioned, the outlets in your those are family, friends, or electrocution. Your home at risk of fire. Your breaker is not going to stop a fire, right? You know it's meant there really to an overload of significant power, right? It's about 20 times what could stop your heart. So he
Yep.
thought, well, why do we live with this? Why do we accept this? What's a better way we could do this to deliver electricity safer, but still supporting the power needs that we have today? As I mentioned, PoE is great, but in order for me to power everything in this room, I would need quite a few PoE cables, to turn this all up.
I'm glad you mentioned that the voltage, the amperage it can stop a heart. It's 200 milliamps, not even 1 amp. So, I mean,
Mm-hmm.
if your heart's not pumping, you're not getting blood or oxygen in the rest of your body, and you're dying. So, I'm glad to hear. I love the fact that it checks 500 times a second and it's looking for those kinds of errors. How do you feel that digital electricity? Because it's been, like I said, I became aware of it about, I want to say about a year ago, but I didn't really dive into it until a couple of the cable manufacturers put out some white papers on it. You were on the show with BS with Todd. And so I was like, I really need to dive into this and look at it. How do you feel that digital electricity is going to affect the low voltage industry that people are doing, you know, voice and data cabling?
I think it's a great benefit. We see, fiber, you know, going deep everywhere, right? You hear about it all the time. Fiber deep, fiber to the this, fiber to the that, right? Fiber is a high bandwidth, long distance technology, right? Fiber, depending on what you're using, can go, 10 kilometers. But, you know, you still have to power the end device, right? You have to plug in whatever that fiber is going to be plugged into. So what we see ourselves as is a high power, long distance technology. So fiber, high width, long distance, DE, digital electricity, long distance, high power. So really pair well with fiber. A lot of these cable manufacturers, hybrid fiber cables, right? Power and data. That's kind of live on today these days, right? There's very few devices these days that are either not powered or communicating, right? Whether that's your watch, your clothes, your Wi-Fi, all that kind of stuff, right? So someday everything's gonna, and it's all about that power and data and how we reduce the complexity of powering these things, right? Right? If you have to find an outlet, every put a fiber device, AC outlet, an AC conduit, a breaker, all those kind of things, but bring it in from two different directions, and that's a code requirement, right? Your fiber pathway power cannot share a pathway unless it's a few caveats for armored cable, things like that. But it's expensive. You got to bring in one contractor for the power, another contractor for the fiber, just to bring it to a single location, right? So the advantages I see of the digital electricity is allows you to do both at the same time, even in the same cable. So now you have an IT closet somewhere in the building. You need to power it up with power, the actual power, and then you need to light it up, fiber, right? You pull one cable, you get both.
Yeah, I just as you were talking, I was thinking of several applications right off the top of my head. Like one, you got a large campus type property and they want security cameras placed, pretty far out. Well, now you can run the fiber would obviously give you the bandwidth for the data signal distribution. And then if you do the digital electricity, you don't have to pay an electrician and run a circuit all the way out there, right? Another
Mhm.
example that I just thought off the top of my head. Let's say you got again another type of campus environment, and and some of your properties have like the guard shack at the front door, right when the front entrance. So you could easily run a fiber with and hybrid fiber has been around for a while. That's nothing new, and you can
Mhm.
run that hybrid fiber out to that guard shack, and it could power up hit their computer to give them the network connection, even cameras. So to me,
Mhm.
let me ask you this question. So in the applications that you've seen so far with digital electricity, would you say it's more towards that type of an install, or do you really see more digital electricity going towards like people using digital electricity to replace the traditional electrical distribution panel in their offices?
I would say it's more the former. So, we're not at a place yet where people are going to replace AC with digital electricity. You know, there's always that, hesitance to adopt new technology. You can't just plug anything into digital electricity and have it turn on yet. So we're not there yet. I know, company has ambitious goals of changing the entire landscape, but in the short term, we're realistic about what we can do and what applications. You brought up a good example. So, and going back to the PoE, right? We don't see ourselves as a competitor to PoE. PoE, I love it. It does a lot, right? And if you have, your PoE switch and all your devices are within a few hundred feet and they only need 90 watts, go ahead and use PoE. That's not an application that digital electricity is going to address. Um, but, sometimes there is that, fence that's longer than a few hundred feet, right? Or,
Mhm.
the guard shack, just has to run. So that's where we see, hey, not as simple as this, but like if over 100 watts or over 100 meters, that's where we can come in. Below that is easily addressed by PoE. Um, but then you have an example of, let's say you want to put a PoE switch out in that guard shack, like you said, cameras, radar, access controls, whatever. You know, Even if that guard shack was within that distance, you'd still have to run a lot of cable out there.
Yeah, I love that example. You're treating it like a hierarchical star, right? It's the backbone to get to the guard shack, and then the guard shack feeds the PoE device, which feeds everything else. Love that example. Love that example. So low voltage contractors, we're pretty adept at pulling fiber, terminating fiber, pulling balanced twisted pair cable, and terminating it, and testing it, and certifying it. Is there any additional training if somebody's thinking about getting into this, whether it's a company or an individual? Is there any additional training that they really should take before they start jumping into digital electricity?
So we don't necessarily have specific requirements around the certification of who's installing this. We kind of like to say it can be done by anybody. So, members of, the low voltage techs and things like that. That's who we try to recommend. In some jurisdictions, it may be required to be an electrician. It all depends on those local laws. But in general, we are dealing with these low voltage contractors and technicians. Um, it'd be kind of the same people running fiber. It's going to be the same people running Ethernet, power over Ethernet. There's not a specific level of training. However, we do like to get involved. So we know it's new. It's a new technology. It hasn't been around for forever, like some of the other ones, right? So we like to be involved in the design and the turn up process. So we have a team of support engineers that we dedicate to new projects, and they will work with the contractor to say, all right, what do you want to power? Where is it? What cable are you using? All those kind of things. So we'll help with the design and give them the C type information that they can give to their customers, and we'll provide sort of a best practices guide of training. Maybe it's only like an hour presentation to the installer saying, look, here are the best ways you can do it to avoid any issues. Again, we want this to go in right the first time, turns right on, you light up your end devices, and everyone's happy, right? It doesn't help us if we just kind of throw it over the fence and hope for the best. So we just working closely with them, and all those things I mentioned, those are free services. We do not charge for the design. We If you buy the equipment, you get that for free. So send us the design, build it up, get your feedback, and then we can say, all right, let us talk to your installer. We can get them trained up pretty quickly, and it's fairly straightforward. There are a few things here and there we've learned over the years that we like to convey, but it's pretty straightforward.
Gotcha. So let me ask you this. So digital electricity, is this a proprietary type system where meaning you're the only ones offering right now, or is this or are there other
Yeah.
people out there offering digital electricity as well?
So digital electricity is proprietary. So we have patents and trademarks and things on that specific technology that we kind of been talking about, the high voltage pulsed
Right.
transmitter receiver. Now, I will say that we are also pushing for a standardization for, your viewers, your listeners may be familiar with the NEC. NFPA
Yep.
70 just launched its 2023 version. And if you love code, you can go all the way down and look at Article 726. There's a new Article 726, so most people are probably familiar with 725, which is what digital electricity is deployed under today. I mentioned that limited power source 62368-1, but coming soon to a venue near you is Class 4 fault managed power systems. So this is a new designation that the NEC has adopted based on the UL 1400-1 spec. And that is, a new section of the code. They're saying, look, we recognize that there is a new technology, a new way of delivering and distributing power in buildings, and it's defined in there. So this is, something we've been pushing for. It's our feeling that, it's great that we're this proprietary technology. We're the only ones can do it. But that limits the size of the pie. We want to grow the
Right.
pie. So if other companies, they may not call it digital electricity, they may have other names for it, other ways of doing it, but it's going to open up the space to have people think about how could we deliver power differently, so that it's safer and it can be delivered with datacom cables and things like that. Now, this may further, some of the divide between the low voltage and the electricians.
You read
But
my
I
mind. You read my mind.
But I think
And that,
there are some ECs out there that are recognizing this as an opportunity, right? There is some people I'm sure are going to say, look, I do my line power or whatever it is, and that's all I'm going to do. But you know, again, these things with power and data, they can be worthwhile. I mean, you might be able to do, if you use digital electricity, you get your jobs done faster, you can get more jobs,
right.
right? So, an opportunity there.
Yeah, it's funny you mentioned the 2023. They published the beginning of November, and I mean, literally, I logged on early to buy my copy, and I was like, I better log into the restream too, just in case Luke gets on, and then I happen to log on and see, boom, you popped up. I was like, so as soon as I get done, I'm actually ordering the 2023 because I'm one of those code geeks. I just am, and you did hit probably chord with some of the people who listen to this audience. There's always been a rub between electricians and low voltage installers, and some of it's justified, some of it's not. But there's certainly a gray area that started with POE. Well, now you're taking over our job, and now I can see with digital electricity, them seeing that even more. So, but the good electrical companies, they're going to see that opportunity and they're going to jump on it and they're going to offer that with everything else. But I do see this being a potential problem between installers and electricians. The people who are actually out in the field doing the install. I can see them. That's our job, especially in areas like heavy union areas like New York, New Jersey, Philadelphia. I could definitely see those being issues there. But I think what this does is it opens up a great opportunity for the end user. Have you guys done any kind of cost analysis on how much a customer might save if by using digital electricity over running a data cable and then running a power cable?
I'm going to give you the answer answer that everybody loves to hear is that it depends.
You
um,
sound like me now.
so, look, like you mentioned, it's like, it's very hard to say that because, where are you? Are you in New York? Does it have to be done by, a union? Are you in, some other place that requires some certificate, some, permits and things like that? What are you powering? How many cables are you running? So I would love to be able to say, here's the dollar per watt we can save you. Here's the dollar per save you. But there's just not, enough around, consistency around the country to say, yes, it's always going to be this. Or what I can say is give us opportunity, show us, you need powered, where you need power it, give us the opportunity to quote it. If it doesn't beat your AC prices, well then, let us know and we'll work on that. But I've been talking a lot about, can we prove that we're cheaper everywhere? It's just not possible. It's not apples to apples, right? PoE and AC, you can't always look at one versus the other and say, oh, this is very cheaper. You need different lights, you need different circuits, you need different cable, you need a different pathway, right? So, I'm pretty confident I can say that we are less expensive than traditional AC power in these applications where there needs data delivered anyway.
Spoken like a true estimator. Have you estimated in the past?
I estimate all the time.
Spoken like a true estimator. As a fellow estimator, I totally understand why you said it depends, because there are way too many variables. But the customer always wants that general. Oh, you can save. I'm gonna make a magic number. You can save 15.5% if you use digital electricity over. The customer always wants that number, but again, there's way too many variables there. Absolutely interesting stuff. I appreciate you coming on today, Luke.
Thank you.
So I hope you were able to glean something from this interview about digital electricity. It's yet another reason why copper's not going away. Just more stuff that we know how to do. It's an interesting opportunity, and it sounds to me like it might be something that you might want to get into. I'll make sure that I put Volt Server and Luke Getto's information in the descriptions down below. Until next time, knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.